Hello everyone, welcome back to Ellie Spectrum. In our last video, we discussed about basics of single line diagram, and today we are going one step further with different type of bus bar schemes. So when designing or analyzing a substation, one of the most critical decisions is choosing the right bus bar scheme for your substation. And what are the key factors for selecting this bus bar schemes? Mainly it is maintenance of a circuit breaker, maintenance of bus bar, reliability, cost, and complexity in overall substation design. Once we briefly go through this different type of bus bar schemes, you will be able to analyze all these aspects by yourself and you will be able to select the most suited bus bar scheme for your substation. So we are going to discuss most widely used bus bar schemes in substation. And these schemes are single bus bar, sectionalized single bus bar, main and transfer bus bar, double bus bar, double main and transfer bus bar, and last is one and half breaker scheme. So let's start with first and simplest bus bar scheme, which is single bus bar scheme. In our last video, we discussed how to construct a feeder, disconnector, earthing switch, CTs, surge arresters, right? Let us consider the same feeder as you can see here. And now let's just extend the bus bar, what we have here, and we put more feeders connecting to the same bus bar. And we have our first bus bar arrangement, which is single bus bar scheme. These feeders could be anything depending on your substation configurations. For example, distribution feeder, transfer feeder, or capacitor bank feeder. Now let's see what are the advantages and disadvantages of this bus bar scheme. Advantages are it is simplest and cheapest arrangement, minimal equipment, easy to operate, and cost effective for small setups. And when we talk about disadvantages, it is mainly related to the maintainability of the complete scheme. So we don't have any redundancy for bus bar or a circuit breaker maintenance. That means suppose if we have a fault in this circuit breaker, this complete feeder needs to be taken out, or it is applicable for any of these feeders. And when we talk about bus bar, suppose if we have fault on it, on this bus bar, substation needs to be taken out of service till we do the maintenance or repairing work of this bus bar. So we can say this is the least reliable bus bar scheme, but it is very cost effective when we talk about smaller arrangements or distribution systems. If this is clear, then let's discuss the next bus bar scheme, that is sectionalized single bus bar scheme. Let's start from where we left, single bus bar scheme, and let's split this bus bar into two parts. So we have one section that is one bus bar and another section with second bus bar, and we can connect these two sections with a bus section bay, which consists of a circuit breaker, disconnector, earthing switch, and CTs. So this bus section bay simply connects two different section of bus bars. So we have one set of feeders connected to this bus bar, another set of feeders connected to this bus bar, and this entire two sections can be connected with bus section bay. And this is our sectionalized single bus bar scheme. So what are the advantages and disadvantages of this scheme? When we talk about advantages, we have one advantage over a single bus bar scheme, that we have sectionalized this bus bar. So the fault is confined to only one section and we can still operate another section by isolating it by bus section B. In terms of disadvantages, it is more or less similar. Section has any kind of fault, then that complete section will go out of operation. And similarly with the circuit breaker, that if we want to maintain one circuit breaker or if there is a fault in one circuit breaker, that complete feeder will be out of operation. So this is also a kind of bus bar scheme which is majorly used for distribution substations. Now let's move on to our next bus bar scheme. that is main and transfer bus bar scheme. We will again take the basis of single bus bar scheme here. Let me tell you is redundancy for circuit breaker. That means we can do the maintenance of circuit breaker without interrupting power supply. Now to do this, we need a special bus bar which is called transfer bus bar. This bus bar is only used for the transfer of power to main bus bar, and at the time only one feeder can be connected to this transfer bus bar. So for this purpose, we need to take a tap just after surge arrestor and connect it to transfer bus bar through a disconnector. Here, for this arrangement, we also need to relocate the CT just after surge arrestor. So in case suppose a power is flowing through the usual path, then we are able to measure the current. And in case we are diverting it to transfer bus bar, in that case also we are able to measure the current. If we are choosing this path of transfer bus bar, then we also need to connect this power again to the main bus bar. And for this purpose, we need one additional bay, which is called transfer bus coupler bay. And this bay consists of circuit breaker, disconnector, earthing switch, and CTs, as you can see here on your screen. Now, the main question is how to divert the power through transfer bus coupler while feeder is on, and that too without interrupting power supply. For this, let's recall how circuit breaker and disconnector operates. So circuit breaker has the capability to interrupt or connect the power supply, while disconnector does not have this capability. However, if the potential on both the side of disconnector is same, then we are still able to switch this disconnector because the potential on both the side is same. And for this kind of operation, we need special type of disconnector which has bus transfer capability. If this is clear, then let's see how to do this. Let us consider that this feeder is connected to main bus bar and the circuit breaker is on. That means the potential on this side of disconnector is same as main bus bar. And to switch on this disconnector, we need to have the same potential on this side as well. To do this, we need to switch on this transfer bus coupler bay so that we will have same potential on both the side of disconnector and we can switch it on. So first, let's switch on this disconnector. By doing so, we will have the same potential or same connection disconnector through transfer bus bar through this disconnector up to this circuit breaker point. Now let us also connect this side of circuit breaker through this disconnector. So we consider that this is closed and the potential from this main bus bar up to this side of circuit breaker through this disconnector is also same. Now if we close this circuit breaker, then we will have same potential on both the side of disconnector through this transfer bus bar, disconnector, circuit breaker, disconnect, and this disconnector. Now, if we close this disconnector, we can all now switch off this circuit breaker as we have one alternate path and the power will be flowing through transfer bus bar through transfer bus coupler and it will be connected to main bus bar. Please remember that we are using transfer bus coupler bay only in case if we want to maintain a particular breaker. Otherwise, this transfer bus coupler bay is not operated during normal operation and all the feeders are connected to main bus bar directly through main circuit breaker. So we can have multiple feeders connected to the main bus bar and we will have one transfer bus coupler bay entire substation for this main and transfer bus bar scheme. Now we can also represent this single line diagram in another way which is more common. So we will be just shifting this transfer bus bar at the bottom of this single line diagram. So the arrangement remains same, but only thing is we are just representing main bus bar on top and transfer bus bar on bottom. Let's see advantages and disadvantages of this bus bar scheme. So in advantages, main thing is that feeders can be maintained without a complete outage, as we can maintain the feeder through transfer bus coupler, and we have greater flexibility than single or sectionalized bus bar scheme. So in terms of disadvantages, we do not have any redundancy in case of bus bar fault, as all the feeders are connected to only single bus bar, and we don't have any redundancy for that. Also, that if we want to maintain more than one feeder at a time, then it is not possible. This bus bar scheme is generally used up to 145 kV voltage in transmission system. This scheme gives better flexibility than single bus bar or sectionalized bus bar scheme with some additional cost. We will discuss about other bus bar schemes in our next video. Thanks for watching ELE Spectrum and see you in next one.